let's do one of your favorite examples here with a hyperbola where we have to do completing the square. So I'm going to group the x's, and I'm going to group the y's. I'm going to move the 113 over to the other side. I now factor out the 9 here. And I'm going to factor out a negative 4. Oh, somehow I made that negative. That should now be negative. Nothing happens to 113. Half of negative 6 is negative 3 squared is 9. 9 times 9 is 81. Half of negative 2 is negative 1. Negative 1 squared is positive 1. 1 times negative 4 would give me negative 4. So the left side now is going to be x minus 3 squared and y minus 1 squared. And when I simplify what that is, I believe I get negative 36. Seems odd to have a negative here, but when I divide both sides by negative 36 to get that equal to 1, what's going to happen is 9 divided by negative 36 will give me negative 4, and 4 divided by negative 36 will give me 9. So I actually need to flip those two and put this one first. So in standard form, my final equation would be y minus 1 squared over 9 minus x minus 3 squared over 4 is equal to 1. So that's to get it in standard form. Now, let's see what the graph's going to look like and get all the things. I'm going to erase this part, but we'll leave the equation down there. Where is the center? Well, the center, remember the x-coordinate always goes first, so I have to pull the 3 and the 1 out. What's A? Well, A is always that semi-transverse axis, so that's going to be 3. B is going to be the semi-converse axis, conjugate, and so that's equal to 2. And if I do Pythagorean theorem, as opposed to an ellipse where I would subtract these, now I'm going to add them up and I'm going to get C is the square root of 13. So notice the y came first. What does that mean? That means this thing's going to open up and down, so that's going to have some effects on some things when we try to find our vertices and our foci. First I'm going to start at 3, 1. There's my center. Now I'm going to go up 3 and down 3 to get to my vertices. 1, 2, 3. So I would have vertices at 3, 4 and 3, negative 2. Notice those changes went to the y. Okay? My foci are going to be square root of 13 up and down. So I'd have 3, 1 plus or minus square root of 13. And so that's a little bit, it's between 3 and 4. So it's going to look something like this. And now I want to set up the box so I can figure out where my asymptotes are. And so I already have the up and down 3, but now I got to go left and right 2. So if I go to left 2, I can now draw in my asymptotes. And I always think it's easier to draw them in and then come up with the equation. So the equation that I would come up with for the asymptotes is y minus 1 equals plus or minus. Now my rise is the a value. Before it was b over a. This time it's going to be a over b. So I'd have 3 halves and then x minus 3. I think that's everything you would need to know for one of these, but this one opens up and down as opposed to the others that were opening left and right. We still have eccentricity, so sometimes they'll ask you for that. And eccentricity is still c over a. In an ellipse, because a is bigger, this thing is always less than 1. In a hyperbola, it's going to be always greater than 1, so I'd get the square root of 13 over 3, and that's its eccentricity.